All right, exponential functions, okay? You guys actually grasp exponential functions a little bit in middle school. And exponential functions is a non-linear function. What's non-linear mean? Not straight, not a line, right? Phones, computers, all of that need to be put away right now, okay? In the form of y equals a times b to the x power. So if you notice, x is my exponent, right? So you know it's exponential when the x is your exponent, okay? Where a and a cannot equal 0, because if a is 0, what's 0 times anything? 0, so we actually have a constant function. B can't equal 1, because if b is 1, if I raise 1 to any power, isn't it still going to be 1? So it won't change our function at all either. It's a constant function, okay? And then b is always greater than 0. So the exponent, or that base of b that's raised to the exponent, is always going to be a positive number. A can be negative, but b has to be positive, okay? As the independent variable, what's my independent variable again? Is that the x or the y? It is the x, okay? As my independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, okay? Which means the consecutive y values form a constant ratio, okay? So linear, remember, if we're looking at a pattern, linear increases by adding and subtracting, right? In exponential functions, our y is going to be multiplied. Let me ask you guys something. Is dividing, can I change dividing to multiplying? Yes. So my y can be multiplied or divided. However, when we say it was divided by 2, when we talk about that ratio, it's actually being multiplied by what? Dividing by 2 is the same thing as multiplying by what? 1/2. Okay, so my ratio would be actually 1/2. If I know it's being divided by 3, what is my ratio? It's being multiplied by 1/3, 1/3, right? Okay. All right. So linear is always adding and subtracting by a constant. The exponential is when we multiply, or technically divide, but we can change dividing to multiplying, okay? So does the table represent a linear or exponential function? Explain, okay? So what do you notice about my x? Yes. There's a constant rate of change, right? We're adding 1 to each time. What about my y? We're adding 2 each time. So is this linear exponential? I would say it's linear. Why? As Chloe said, it's a constant rate of change. Okay, because my y changes by plus. Does anyone know my slope then? Because constant rate of change is my slope. You don't have to do this, but what is my slope? Can anyone tell me? How do we remember slope? It's the change in y over the change in. What's my y change? 2. What's my change in x? 1. So isn't my slope just 2? Yeah, so my constant rate of change is 2. That's why it's the same. Okay. All right, let's look at B. My x is still increasing by 1, but what is happening by my y's? It is being multiplied by what? 2 each time. So would this be linear or exponential? It's exponential. Why? Because my y is being multiplied by what? By 2. being multiplied by a ratio of 2. So if you notice, the x in both linear and exponential increases by the same amount, right? It could be +1, it could be +2, it could be +3, or they could go down, right? Plus a -1, plus a -2. But it's the y that makes the difference. If the y is being added or subtracting, it is linear. If it's being multiplied or divided, it is exponential. Now, however, you guys have to remember, if this was going down and it was dividing by 2, when we say exponential, it's being multiplied by what? If we notice that it's actually being divided by 2, we're going to say it's multiplied by what? 1/2, right? We always have to change it to multiplication, not division, okay? All right, evaluate. What does evaluate mean? Solve. Plug it in and solve, okay? So evaluate for the value of x. So x equals 3. So do you think you guys could plug 3 in here and evaluate it? Yeah. So y equals -2 times 5 to what power? 3. Now, follow orders of operation. Do I multiply or do I do my exponent first? My exponent. So what is 5 cubed? So what's 5 times 5 times 5? 125, right? And 125 times now that -2 is -250. Okay. Evaluate. Plug in solve. All right, let's look at B. Y equals 3. And I'm going to put this as a fraction because I like fractions better. What is 0.5 as a fraction? 1/2. Raised to the x power. And what's my x? -2. What does a negative exponent do? How do we get rid of negative exponents? We have to flip it, right? So could I go ahead and before I distribute it, could I go ahead and just flip my fraction? Yeah, I can make this as 2/1 to the second power, couldn't I? Yeah, because when you flip it, it gets rid of that negative exponent, right? Now, 2/1 is just the same thing as what? 2. And now, does that look a little bit easier for you guys to do? Yeah. What's 2 squared? 4. And what's 3 times 4? 12. So y just equals 12. All right, any questions with that so far? No. All right, let's go ahead. And I want you guys to do these 4 problems. Linear, exponential, explain. And then I want you to evaluate when x is -2, 0, and 1/2. Okay. So we have 3 answers, 3 problems to do down at the bottom. Okay, I am going to give you guys till 30, let's do 37. At 10:37, we'll go through these problems. Okay. 10:37, and then we'll go through these problems. Okay. So is everyone at home? Are you guys okay so far with this?
Yeah.
Okay. guys doing okay so far, everyone? You guys ready for me to go over this, or do you want a couple more minutes? Let's go ahead and go over. Number one, okay, you notice, what do you guys notice about the x's? Increases by 1, good. What about my y's? Each time it is what? Dividing by 2, right? So since it's dividing by 2, what's another way to write dividing by 2? Multiplying by 1/2, right? So since my y is being multiplied by 1/2 each time, is this linear or exponential? It's exponential. Why? Because the y is being multiplied by the ratio of 1/2, right? Good. All right, B. Okay. X is increasing by what? 4. Is that okay? Yeah, it's okay. It's increasing by 4 each time. It's the same. It's constant. What about my y? It's subtracting by 1. So is this linear or exponential? This one is linear. Why? It has a constant rate of change. I forgot the word rate. All right. Now, what does anyone know? What's my slope? What is my constant rate of change? -1/4. Why? Because it's a change in y over the change in x. So -1/4. Good. All right. Evaluate when x is -2, 0, and 1/2. Okay. So we're just plugging in, right? So y equals 2 times 9 to the -2nd power. We have a negative exponent. So how do I remove a negative exponent? Move it to the bottom, right? So this is 1 over, what's 9 squared? 81. So 9 to the -2nd power is 1 over 81. Now what's 2 times 1 over 81? Remember, 2 is the same thing as 2 over 1. So 2 times 1 is 2 over 1 times 81. 81. So we just have 2 over 81. Okay. All right, when x is 0, 2, y equals 2 times 9 to the 0th power. What's anything to the 0th power? 1. And 2 times 1 is 2. Good. Great. and then the 1/2. We have to do a little thinking here, don't we? Can I use the exponent of 1/2? No, we have to do what we did in 6-2, right? So what root of 9 am I looking at? What root of 9? Is it the 1 or the 2? 2, and we're going to raise it to the first power, which is the same, right? What's the square root of 2? Or square root of 9? Sorry. What's the square root of 9? What two numbers multiply to be 9? 3. 3 to the first power is 3. And what's 2 times 3? There you go. Any questions with that? Can't see that. Sorry. I can see it over here. All right. The next one. What's 1.5 as a fraction? I like fractions better. What's 1.5 as a fraction? 1 and 1/2, which isn't that the same thing as 3/2? Now, if you left it as 1.5, that's fine. But if you don't have a calculator, multiplying by 1.5 is a little harder than a fraction, isn't it? Yeah. Okay. So then we're going to multiply that by 2 to the negative second power. Can I have a negative exponent? No. So what do I have to do with that? Move it to the bottom. So we have 1 over, what is 2 squared? 4, right? You guys okay with that? So now we have 3/2 times 1/4. Can we go ahead and just multiply straight across? Yeah. 3 times 1 is 3, and 2 times 4 is 8. So we just get 3/8. And I think multiplying 1.5 times 0.25 would be harder than just what we did. Don't you guys think? I think so. All right, 0. So 3/2 times 2 to the 0th power. What do you guys get? 3/2. Why? Because 2 to the 0th is just 1. And 1 times 3/2 is 3/2. All right, 1/2. 3/2 times 2 to the 1/2 power. What root of 2 am I taking? What root of 2 am I taking? The second power, right? Let me ask you, can I take the square root of 2? No, I can't. So guess what? I'm just going to leave this as the square root of 2. And there you go. I didn't mean to do that. It just happened. Okay. Any questions with this so far? Pretty easy. Okay, that's part of your homework. Okay, that's online. I think you guys will be able to do that. Now let's look at our graphing. Okay. All right. So there's 4 different types of graphs that I can look at. Okay, and they kind of put all of this a little bit together. Okay. When I look at this, okay, if we have the function of y equals a b to the x power, okay, if b is greater than 1, so what numbers are greater than 1? 2, 3, 4, 5, 6. 3/2, right? 1.5. 2.5, right? Those are all bigger than 1, okay? Your graph is going to either increase to the right or decrease to the right, okay? Now, if you notice this, both of these graphs never cross what? The x-axis, right? Exponential graphs never intersect the x-axis. So if I go to ask you to graph things, if you cross the x-axis, I'm going to mark it wrong. It will always approach, but never cross the x-axis. Because, guys, well, why? Okay, when you do this, would we ever get 0? No, because a can't be 0, can we? Our y can never be 0 in this sense, okay? Now, when a is positive, When A is greater than 0, it will be above the x-axis. And when A is negative, it will be below the x-axis. Makes sense, right? Because if I multiply by a positive number, won't my y values be positive? And if I multiply by a negative number, won't my y values be negative? So that's why it comes below. It's a reflection, okay? So what's domain again? We talked about domain before. What's domain? It's the x values. I could plug in any value for x, couldn't I? Yes. So my domain is going to be all real numbers. All real numbers, okay? You can also write it from negative infinity to positive infinity. This means the exact same thing, okay? Either writing all real numbers or negative infinity to positive infinity, okay? Your range. The range is my y values, right? If I'm above the x-axis, y is going to be greater than 0, right? And this is for when you're above the x-axis, meaning A is positive, right? When we're below the x-axis, when you're below the x-axis, y would be negative, so y is less than, right? 0. And that is when A is negative. A is negative, less than 0. Okay. Now, if you notice, looking over here, when B is between 0 and 1, what numbers are between 0 and 1? 1/2, 2/3, right? Fractions. If you notice, do you see how it decreases to the right, increases to the right there? Okay, it kind of flip-flops, right? You guys okay with that? All right. So now what we are going to do is we're going to graph these. And I'm actually going to use the worksheet because they're a little bit bigger. So let's go here. Okay. So let's look at this worksheet. Okay. Now, I'm just going to talk a little bit about things, okay? A in number 1 is positive, right? So if A is positive, do you think we're going to be above or below the x-axis? Above. Since A is positive, we're going to be above the x-axis. Okay. This is my B. B is greater than 1, right? So if B is greater than 1, we know we're going to increase to the right. So it's going to look something like this. All right. Now, how do we figure out what it looks like? We're going to make a table. Do you guys know how to make tables? Do you know how to make evaluate? Yes. So we're going to make a table. And our tables are always going to be the same values for x. We're going to use -2, -1, 0, 1, and 2. And then that will be our y coordinate. Okay. Now, I left the space in the middle. And why do you think I left the space in the middle of this? Just so you can show your work. All right. And the work will be when you evaluate your function. Do we know how to evaluate? Didn't we just do it on the front side? Yeah. Okay. Now, here's my question. Do you guys want to start with positive or negative numbers? Huh? Let's start with positive. Let's start down here at 2. Okay. Let's start here down here at 2. All right. So let's plug it in. 4 times 2 to the 2nd power. What's the order of operations say? Exponent first, right? What's 2 squared? 4. So 4 times 4 is? So could I graph the point 2, 16? Yeah. So I'm going to go right 2 and up to 16 and put a point. That's okay with that. Let's do the next one at 1. 4 times 2 to the 1st power. What's 2 to the 1st power? 2. And what's 4 times 2? So can I graph the point 1, 8? Yes, I'm going to go right 1 up to 8. Let's do 0. 4 times 2 to the 0th power. What's 2 to the 0th power? 1, and 4 times 1. Can you graph the point 0, 4? All right. Everyone okay with this so far? All right, let's do -1. This is where, when you think of -1, can you have negative exponents? No. So I look at it when I do this is, we know 2 to the first power is 2, right? 2 to the first power is 2. So 2 to the negative first power would be, wouldn't that be 1/2? Yeah. And what's 4 times a half? What's a half of 4? 2. So could I graph -1, 2? -1, 2. And if you notice, do you guys see a pattern each time? What's my pattern? Going from backwards, right? 16 divided by what is 8? 2. 8 divided by 2 is 4. So 4 divided by 2 is 2. So what's 2 divided by 2? 1. So this last number is actually going to be 1. So can I graph -2, 1? Now, could we do that work if we wanted to? Yeah. 2 to the -2nd power, isn't that 1/4? And a fourth 1. Now, when you draw your curve, again, what can't I cross? The x-axis. So as you curve this, you just want to make sure you approach the x-axis, but you never actually cross it. And there's your graph. Yeah. We're almost done with this. Yeah, just give me about maybe 5-10 minutes. Can you hold it that long? Okay. All right. Let's do number 3. And I want to, yeah, we'll do number 3 first. All right, let's look at number 3. Okay. Was everyone okay with that? Am I okay to move? All right. So again, A is positive, right? So are we going to be above or below my axis? We're going to be above the axis, right? So above the x. Now, my B is between 0 and 1, right? So what happens with my curve? So here's my original one. B was greater. Now it's in between 0 and 1. So what's going to happen? It's going to reflect and it's going to go the other direction, okay? So now instead of increasing that way, it's decreasing. So it's going to look something like that, okay? All right, so let's make our table. X. And what values did I tell you to use for x again? -2, -1, 0, 1, and 2. My work and y. All right. Do you guys want to start with positive or negative numbers? You guys want to start with positive or negative? Positive? Okay. So 3 times 1/2 to the 2nd power. What's 1/2 times 1/2? 1/4, yep. And 3 is the same thing as 3 over 1, right? So what's 3 over 1 times 1/4? 3 over 4. Now, could I graph 2 and 3/4? Where's 3/4 located? Between 0 and 1, right? Closer to what? 1, right? So wouldn't it be something way down here? Okay. All right, let's do 1. 3 times 1/2 to the 1st power. What's 1/2 to the 1st power? 1/2. And 3 is the same thing as 3 over 1. So what's 3 over 1 times 1/2? 3 over 2. 3 over 2, isn't that 1 and 1/2? Yeah. So could I graph 1 over 1 up 1 and 1/2? Yeah. So over 1 up 1 and 1/2. So not yet to 2, but we're getting there. All right, next one. 0. 3 times 1/2 to the 0th power. What's anything to the 0th power? 1. And 3 times 1? So could I graph 0, 3? Okay. Now, looking at the pattern, isn't that a little bit more challenging? So we're going to keep going here. All right, so let's do -1. 3 times 1/2 to the -1st power. Ooh, can you have negative exponents? No, so what do you do with that fraction? You flip it. So this is just going to be 3 times 2 to the 1st power, right? Because 2 over 1 is just 2, right? What's 2 to the 1st power? 2. And what's 3 times 2? 6. So can you graph -1, 6? Now, do you guys see your pattern a little bit or no? No, that's okay. Let's do the last one. 3 times 1/2 to the -2nd power. We have a negative exponent, so what do I have to do with that fraction? Flip it, which is just 2, and then that -2 becomes a +2. So what's 2 squared now? 4, and 3 times 4 is 12. So could you graph -2, 12? Now, as I draw my curve going down, what don't I cross? The x-axis. So we make sure we approach it, and you always put arrows at the ends. Why? Because they keep on going, don't they? They never stop, never. Because my domain is always, for every single one of these, my domain was what? What's my domain? All real numbers. Or you could say -infinity to +infinity. Now, my range actually for both of these, because they're above the y or the x-axis, we know our y values are always what kind of numbers? Positive. So y is always greater than what? 0. Can the equal 0? No, because then it would cross the x-axis, right? So y is just greater than 0. All right, let's flip this over, and I'm going to change a couple of these. I want to change number 6 to a -4 in the beginning. And we'll do number 5 and make that a -1/2. Okay, so we're going to do 5 and 6, and then I'll let you guys work. Okay. All right. Let's do 6 first. All right, now my a is what kind of number? Since I changed it, a is negative. So we're going to have to redo my graph a little bit. So since a is negative, what is going to happen with my graph? Is it going to be above or below the x-axis? It's going to be below x. You guys okay with that? Actually, I might not do that wrong. All right. Now, b is between 0 and 1, right? So we know it's going to go in this direction, right? If it was greater, it would go the other direction, right? Okay. So now, making our table, again, what values do I pick? -2, -1, 0, 1, and 2. All right, and 1. All right. And then our work. Now, do you guys want to start with because my b is a fraction, do you guys want to do negatives or positives first? Let's do negatives, because what happens when it's a negative? Doesn't it flip it to make it a whole number? So let's go ahead and do -4 times 1/2 to the -2nd power. We have a negative exponent, so what do I have to do? Flip it, right? So it'd be 2 to the 2nd power. Okay. What is 2 squared? 4. And what's -4 times 4? -16. Are you guys okay with that? So now, obviously, I would have to change this, right? So let's make my x-axis up here. And then this will be -2, -4, -6, -8, -10, -12, -14, -16. You guys okay with that? All right. So now -2, -16. All right, let's do -1. -4 times 1/2 to the -1st power. Negative exponent, so what do I have to do with this? Flip it, right? To the first. So 2 to the first is 2. And what's -4 times 2? -8, right? So -1, -8. 0. -4 times 1/2 to the 0th power. What's anything to the 0th power? 1. And what's -4 times 1? -4. Is everyone okay with that? Okay. All right. Now 1. -4 times 1/2 to the 1st power. What's 1/2 to the 1st power? 1/2. And what's 1/2 times -4? What's 1/2 of -4? -2. Yep, so we have 1, -2. Does anyone see a pattern here? Each time it's getting divided by what? 2. So what would be my next answer? Huh? -1. Yeah, -1. And then again, here's my curve. Make sure you do not cross what? The x-axis. There you go. All right. How do you guys feel with this? It's not too bad, is it? No. Okay. All right. So we'll go ahead and stop here. You guys have 14 minutes